Hi everyone. Today we're going to study relationship between zeros and coefficients of a quadratic polynomial. We learned that zero of a linear polynomial ax plus b is the negative of b over a. We can see here that the constant b is in the numerator while a, which is the coefficient of x, is in the denominator, and this is negative. We will now see relationship between zeros and coefficients of a quadratic polynomial. If alpha and beta are the zeros of the quadratic polynomial p of x equals ax squared plus bx plus c. A is not equal to 0. Then x minus alpha and x minus beta are the factors of p of x. Therefore, ax squared plus bx plus c equals k times the quantity x minus alpha times x minus beta. Here, the k is a constant. Let us multiply this x minus alpha by x minus beta, and it will be like this. K, the constant outside, we have x squared minus the quantity alpha plus beta times x plus alpha times beta. Now, this k outside, let us distribute to all the terms inside. We have now this k x squared minus k times the quantity alpha plus beta times x, then plus k alpha beta. Now let us compare coefficients of x squared, x, and constant terms on both sides. On the left side, the coefficient of x squared is a. On the right side, the coefficient of x squared is k. So we write a equals k. For the coefficient of x on the left is b. On the right side, the coefficient of x is negative k times the quantity alpha plus beta. So we write it here. For the constant, we have c on the left side. On the right side, we have this k times alpha times beta. So we write it here. When we take the ratio of this b over a, we will derive this relationship that alpha plus beta equals the negative of b over a. Further, if we take the ratio of this c over a, we will have this relation. The product of alpha and beta equals c over a. Example 1. Find the zeros of the quadratic polynomial 2x squared minus 8x plus 6 and verify the relationship between the zeros and the coefficients. Let us factorize the trinomial by splitting the middle term. Our middle term here is the negative 8x. So, we're going to split as a sum of two terms. There is another thing that we should consider, that the product must be 12x squared. This 12x squared comes when we multiply 2x squared by 6. So, the trinomial 2x squared minus 8x plus 6 is now equal to 2x squared. We split this negative 8x into negative 6x and negative 2x. When we multiply the two terms here, we will get this 12x squared. And then the constant plus 6. What we're going to do here, we're going to group the first two terms and the last two terms. In the first two terms, there's a common factor, and that is 2x. What remains is the x minus 3 in the first group. Then, in the second group, there is a common factor, and that is the negative 2. When we factor it out, what remains in the second group are x minus 3. In these groups, there is a common binomial, and the common is the x minus 3. We can factor it out. So we have 2x minus 2 times the x minus 3. In our first factor here, a number 2 is common again. We can factor it out into 2 times x minus 1. Then we copy this x minus 3. Let us equate each factor with variable to 0. So we have this x minus 1 equals 0, x minus 3 equals 0. When we solve for x, in the first equation, x is equal to 1. In the second equation, x equals 3. These are the zeros of our polynomial, or we say these are the alpha and beta respectively. Now let us verify the relationship between zeros and the coefficients. Take note that in our polynomial, the value of a is 2, the value of b is negative 8, the value of c is 6. Now let's begin with the first relationship. The sum alpha plus beta equals negative b over a. Let us substitute the corresponding values. So we have 1 plus 3 equals the negative of negative 8, that is b, over a, which is 2. 1 plus 3 is 4 equals, the right side is also 4. The first relation is verified. The second relation is alpha times beta equals c over a. The values will be 1 times 3 equals 6 over 2. On the left side, it is 3. On the right side is also 3. So, they are equal. It means the second relation is also verified. Example 2. Find the zeros of the quadratic polynomial x squared plus 7x plus 10 and verify the relationship between the zeros and the coefficients. We are going to equate our polynomial to 0 and solve for x. So we write x squared plus 7x plus 10 equals 0. Let us solve the polynomial by factoring. So we have x plus 5 times x plus 2 equals 0. Let's equate each factor to 0 and solve for x. The first factor, x plus 5 equals 0. The second factor, x plus 2 equals 0. When we solve for x, in here, x equals negative 5. In the second equation, x equals negative 2. These are the zeros of our polynomial. Now let us verify the relationship. In the first is the sum relation. Alpha plus beta equals negative b over a. Let us substitute the corresponding values. Negative 5 plus negative 2 equals the negative of b is 7 over a, which is 1. The left side is negative 7 equals the right side, which is negative 7. So the first relation is verified. Second relationship, alpha times beta equals c over a. When we substitute the values, we have negative 5 times negative 2 equals 10 over 1. The left side is positive 10, while the right side is also positive 10. They are equal. So the second relationship is verified. Example 3. Find the zeros of the quadratic polynomial x squared minus 3 and verify the relationship between the zeros and the coefficients. Take note that the a value here is 1, b equals 0. There is no x variable, and c equals the constant negative 3. Now let us equate the polynomial to 0 and solve for x. So we have x squared minus 3 equals 0. When we solve for x, we can transpose this negative 3 to the right. So we have x squared equals 3. And then we take square root of both sides so that we can cancel the power 2 here. So square root of x squared equals plus or minus the square root of 3. The left side will be simplified into x, and on the right side, we have the two values of x, the square root of 3 or negative square root of 3. These two values are the zeros of the polynomial. Now let us verify. Alpha plus beta equals negative b over a. When we substitute the values, we have square root of 3 plus the negative square root of 3 equals the negative of 0 over 1. The left side is 0 equals the right side is also 0. So the first relationship is verified. Next, alpha times beta equals c over a. We substitute the values. Square root of 3 times the negative square root of 3 equals the negative 3 over 1. We multiply the radicals on the left. We have negative square root of 9 equals the right side is simply negative 3. We simplify the left side as negative 3. That is now equal to the right side, which is negative 3. Therefore, the second relationship is verified. Example 4. Find a quadratic polynomial, the sum and product of whose zeros are negative 3 and 2 respectively. Let the quadratic polynomial be ax squared plus bx plus c, and its zeros be alpha and beta. Given we have the alpha plus beta, the sum equals negative 3. The product alpha times beta equals 2. Remember that the sum relation is equal to the negative of b over a, and the product relation is equal to c over a. Take note that the sum and product are given as integers, meaning we can assume that a equals 1. If that happens, in the first relation, we can get that value of b, which is positive 3. While in the second relationship, we can get the value of c. With a equals 1, c equals positive 2. Therefore, one quadratic polynomial that fits the given conditions is x squared plus 3x plus 2.